So this lecture is on the historical development of the electric force. It says the characteristic of scientific progress is our knowing that we did not know. Just as gravity had a whole bunch of contributors to the development of our current understanding of gravity, so did the electrical force. In fact, it has more involved than we actually had in gravity. So you should understand the development of the current models of the electric force, and you should be able to name significant contributors and their experiment that helped develop this particular model. So first of all, we start off with Thales. Thales is considered one of the very, very first scientists. He was a Greek philosopher. He was a brilliant mathematician. He was the first one that was able to record the height of the pyramids because the people who had actually built the pyramids couldn't remember how big they were or even how to measure it. And he measured it using shadows. He was the first to record quote-unquote static electricity. What it was amber rocks. Amber can hold a charge much better than a lot of things, and so because of that, he actually recorded this static electric charge. Then we go up to Robert Boyle. Robert Boyle is the one who developed Boyle's law that you learn in chemistry, which was P1V1 equals P2V2, which is actually a physics principle. But he was the first one to actually develop this law, but he actually recorded he's the first record of an attractive and a repulsive electric force. So he was the first one to say, hey, sometimes the electric force attracts and sometimes the electric force repels. Then we come to Ben Franklin. Ben Franklin is obviously a famous American. He was a printer, a writer, a diplomat, a scientist, an elder statesman. He helped write the Declaration of Independence. He was an ambassador to France. But he was also a very famous scientist. One of the first things that he did was he was able to determine that there were negative and positive charges, and he was the first to explain the law of conservation of charge. He was also given credit for discovering that lightning was in fact electricity, and that he in fact invented the lightning rod as a way to keep houses and buildings safe from fires. Specifically churches more than anything. And he was also the first American, he developed the first American library, public library, and the first American fire department as another means of trying to prevent these fires that were caused by lightning. So the famous Franklin experiment was he held the key that was tied to a kite and it was struck by lightning, and he was like, oh yeah, that's electricity. If he did that, he'd probably be dead. Well, he's dead now, but he'd probably be dead as soon as that happened because lightning is an extremely powerful electric current, and if he were to hold on to a key, that would be a problem. So what he did is he knew about grounding, and he knew not to hold the key. What he did is he had different hairs that were set up, and those hairs would become charged as lightning struck the kite because there'd be an electric current and there'd be induction that would occur. But he definitely did not hold on to the key as shown most often. All right, so Thomson, he studied cathode rays, and they were produced whenever you take an object and you put electricity through it. It actually produces this ray right here, and this ray can be deflected using a positive and a negative plate. And so what he actually discovered is that there was such a thing called electrons. And he used it to develop his model of the atom, which we'll get into later. But basically, he discovered the electron, and then he thought there was this diffuse positive charge. He didn't really know about the proton at this point, but we did know about the electron. So he actually discovered the finite negative charge. He called it a corpuscle of negative charge. And we go to Joseph Priestley. He was a priest and philosopher, and he's actually given credit for being the first one to isolate oxygen from just normal air. But how he's significant in this particular instance is he actually predicted an inverse square law for the electric force, which was very similar to gravity. So he predicted that there was going to be kind of a proportionality between distance and force, just like there was for gravity. And that led up to George Augustin de Coulomb. The next lecture is actually titled Coulomb's Law because we're actually going to look at the relationship between charge, force, and distance, but he was the one who actually determined the relationship between force, charge, and distance. And he also investigated the distribution of charge and how it also always spreads to get as far away as possible. And then we go to Luigi Galvani. Luigi Galvani is given credit for the galvanometer, which actually allows you to measure very, very small electrical values. But what he's most famous for is kind of a Frankenstein type experiment in which he was able to show that the muscles of various animals are actually controlled by electrical impulses. And how he did that is he actually took frogs that were dead, and sent electrical currents through these dead frogs, which actually caused the muscles of that frog to twitch. And that kind of led way to the whole Frankenstein, what are we doing? Are we going to reanimate people who are dead sort of conversation? But he actually was able to show it with frogs and other animals, and there are some rumors that he even did it with some corpses of humans to kind of reanimate them. But the muscles are controlled by electrical impulses as well. Robert Millikan, he was the one who actually measured the charge of an electron. So that E value that we said was 1.6 times 10 to the negative 19th in the previous lecture. He actually said he was the one who measured that, and he won the Nobel Prize for it. He also measured Planck's constant, which we'll talk about a little bit later in life. He was actually a very brilliant experimentalist. So the way that he did it is actually pretty brilliant. What he did is he had these oil droplets, and he suspended them in what was a known electric field. So he knew what this electric field was, and he was able to take an oil droplet, which was charged, and he was able to suspend it. In other words, to keep it floating right here in between the plates. Well, whenever he was able to keep it floating in between the plates, what that meant was that the electrostatic force was equal to that of gravity. So he was able to measure the charge of this particular thing and demonstrate that that represented the charge of an electron. So you should understand the development of the current model for electric force being, force is equal to the charge, is related to the charge and the distance between them. You should be able to name the significant contributors and what they did and what their experiments were that actually helped develop this particular model.